So this is just I'll flick you through a quick demo of Acunu Analytics, mainly driven by our dashboards tool. I'll give you a bit of a demo first of a data set that we've been collecting from the transport authorities in London about the location and arrivals of buses across the city. London being a pretty busy place, I think there are of the order of 20 arrivals of buses every second, believe it or not, at peak times, which is so maybe it's not big data, but it creates a relatively interesting an interesting data set that we can play with and do a few things with. So the first thing to point out is that all of these dashboards are completely customizable and configurable by the end user. So one of our sales guys put together this dashboard just playing with the data set once we plug that data set in. The second thing is that they're completely in real time. So these guys are going to collect data from the underlying cubes, and they're updating in real time. So here you can see arrivals in Islington Green, which is a bus stop, at a particular time, so divided up by the last hour. And you see there's sort of visual query builder that you can use to build these things. So we're doing a select count. We're choosing line name as one group and time and the minute bucket as a second group. And you see we're spreading those over. So we specify some time. You can specify relative time so that you always get the latest data. Obviously, pretty important for a real-time system. And we're specifying another parameter in this where clause here around Islington Green. So these are data items which you can turn on and off. You see we've grouped by the actual line name as per that query here. So you're seeing various different items that resemble different. Each of these numbers is a different bus or set of buses that are coming through this particular bus stop. Wow. And we have a range of different widget types, a range of different things that we can display here. So over here in this corner, we've got a pie chart where we're separating out. Let me go back to that. I clicked that a little too soon. So up here in this corner, we've got a pie chart of the most common bus lines that are arriving at a particular bus stop in the last hour. So it's just a simple pie chart here. What I can do here is we've set up this table so that you can actually drill through onto it. So, for example, if you actually want to see the 73 buses which have arrived at Islington Green, you can click through, and these are the actual items that made that up. So you can see each of these is a JSON, actually resembles a JSON event. I can click Get Events and download a JSON file to get that, that shows you that what we're doing here is maintaining a bunch of indices which are sort of more than just a bit of counting. We can support multiple different lines on a chart so that you can overlay these things. We provide you with a bunch of different types of line charts as well. So I just changed that from a stacked chart to a not stacked chart. And some of the interesting things that you can do with that is to make comparisons between historical data and current data, as I mentioned. So down here, what we're looking at is what's happened today versus what happened a week ago. And if you're astute, you'll observe that actually we turned the data stream off for the majority of the last day, and only started collecting data again a few hours ago. But that's useful for understanding deviations from expected behavior, which is an important part of operational monitoring. So all of this is actually powered by a set of tables or a couple of tables which have a set of cubes. So this is you can set these up via the UI or, of course, also via a command line tool. I'll just sort of step through just at a high level some of the properties of tables here.
Can I just ask a very simple question, just so I've got this straight? You've shown us the various visualizations of the data. So I'm kind of curious as to you organize a data stream coming in. So what else do you need to do in order to get you to the point where you can just start selecting various visualizations? That's kind of what I'm interested in the process here.
Good question. Good question. So that's exactly what I was going to cover right here. So how do we get the data in here? So a table is the place where you push data to. You push data to this particular endpoint here. So you can see that we actually have a load generator built into the UI, but you can see that all you need to do is basically post events to here to start collecting data in. So when a JSON object, or when you do a HTTP post to that address, you then set up some fields which allow you to understand some of the structure that comes in. We're obviously supporting semi-structured events. You only need to specify fields which you care about being able to graph. And in fact, some of the features we've been working on recently auto-detect all of this from your data set, just to make that step of the process even simpler.
Right.
And so the next step is to define some cubes. So the cubes allow you to specify, essentially specify what things you're interested in building very rapid answers for. So what you're seeing here is you're specifying a number of these parameters up here in a where clause and in a group by clause, and that's all that a cube needs to do. So all of the other parts of the queries, so the actual instantiation of any of these parameters, joins or limits or havings or arithmetic operations. So you can say where sum of x divided by min of a minus max of a, those sorts of things. None of that needs to be specified at cube time. You can do all of that at query time. The only bits you need to say at cube time are, these are the parameters that I want you to organize into roll-ups. So these are the dimensions across which you should roll up data, and the group bys are the elements that I want you to be able to split those roll-ups across if I want a set of adjacent items. So in the example I gave earlier, time is a very common item in a group by. So having time in a where clause and having time in a group by as well essentially means that we will maintain buckets across the various different granularities given in the time field here, where you've got day, hour, and minute, and we'll, for each of those, also maintain contiguously located buckets for every sub-element of time. So, you can say where time is between 10 o'clock and 11 o'clock, group by minute, and then we'll pull that data out. So that's really the process of actually getting the data in. So to actually build a dashboard, you can use something like the Explore view here. So just to sort of pick a slightly different example, say I'm interested in knowing the number of different bus registration plates which have appeared on a particular bus line. What I can do is write a query in here. I can run that query. Any of the queries that you set up in your cubes are available here. We're also working on an expanded workflow so that every single option that you could possibly want is available here, and we'll either automatically do an ad hoc query or move that through, or get it out of the queue if it's available. Otherwise, do an ad hoc query, and then allow you to basically click a big, make this real time button, so that once you're happy with a particular query, you can then just immediately add that to a dashboard, and it becomes instantly real time.
Wow. And in terms of the query logic, that's it there at the top of the screen. That does everything. Is that the way?
Yeah. So if I click the AQL tab next to it, you can see that what we're actually doing here is something which is very probably pretty familiar to most
Yeah.
SQL users. So saying select count distinct registration number from arrivals where time is between two different times and line name is 38, group by time hour. So then once you're happy with that, you can give that a name and then add it to either a new dashboard or an existing one. Like that. And there's our widget.
Wow.
So yeah, I mean, I can give you another example as well of going sort of through that process, if I can find the right window. So,
well, while you're doing that, can you just ask a basic question in terms of how people use this? Because certainly you could have individuals who are trusted to ask questions to set up these particular visualizations, but you might just be wanting to provide this to someone. So is this kind of a hierarchy of users in this, in terms of the way that Acunu works?
So in the version that's available to download today, it's all the dashboards are shared with every user. Right now, we are working on security functions which provide a role-based access pattern for dashboards and also for tables to give you almost like write-only credentials. Because
right, that's the question I was asking, but you actually expressed the answer better than I asked the question. Good.
Right. So I mean, yeah, we've had that request from a number of enterprise users. So some of the companies that are our customers use Acunu Analytics in a very collaborative environment. But even there, you see there are often users who are admins and users who only want to be able to view data that's related to their sales area, related to their area of operations, and as often as not, it's to avoid mistakes. So we do have some, so we're building that security model right now, and that will be in our next major release. One thing you can do is if I can remember how to do this, you can create parameterized dashboards where you can so what we support is parameterized dashboards as well. So when you're configuring a widget, you can write essentially a dollar parameter into any of these fields here.
Oh, right. Okay, get you.
So you can say line name, dollar line, and then at the top pops up a parameters box saying pick your line, and it's just a little drop down. And so say you're managing infrastructure across 3 data centers. If you want the same dashboard but to be able to flick it between different data centers, it's a very straightforward way of doing that.
Right. Yeah. Good.
So yeah, let me show you another. Okay, yeah. So I'm just going to show you the command line tool as well. So what we have is all of the things that you see here. You can do either via the HTTP interface or via this command line tool. So, for example, you've got a bunch of commands here which are rather similar to the sorts of commands you would expect you would get with MySQL. So what I'm going to do is I'm just going to show you this is connected to an analytics instance at the moment. List shows you the tables you've got, and I'm just going to show you this table called CDRs. So we work with a bunch of customers who are collecting data which has geographical coordinates associated with it. So, one that I mentioned on Tuesday, Halo, are basically a geo-dating agency for taxi drivers and for customers. And every piece of data that they collect has geo coordinates on it. A lot of their service is about helping taxis find customers that are nearby, helping customers find taxis that are nearby, understanding the route that a driver takes in order to be able to accurately map and maintain a database of predicted prices for customers, and to be able to provide feedback to drivers. So, an interesting use case for Acunu Analytics there is that the drivers app actually provides suggestions to drivers on where drivers should drive to in order to find areas where supply for cabs is greatest or in greatest disparity with demand. And all of that is enabled by maintaining, in fact, they use geohashes, but essentially geographical information. And because of the cubing and bucketing approach that we have, we can organize data that is of a geographical nature in quite an effective fashion. So here I can show you a table. This is the sort of AQL definition to create a table here, which just has like 3 very simple fields in it. This is just like synthetic data. So a latitude and longitude, say, and double is a type which allows us to maintain a hierarchical aggregation over different granularities of a floating point number. So, every latitude we throw at this will be maintained in a sort of 1 degree bucket, and also in a 0.1 and a 0.01 degree bucket. That's the same for longitude. So what we do then is we create this table. We say these are fields which we're interested in. There's also a type there as well. And we say create cube, select count, where lat, where long, group by lat long. So what that's doing is saying, create me a set of buckets across these latitude and longitudes, and also be able to group by them. So what that really means is that I want to be able to ask queries across those areas. So I'm just going to generate a few of these things using a simple load generator, which is literally just a few lines of code to do some HTTP posts. And one of the visualizations we've been building is where you can visualize these geographic cubes across maps. And so if I actually start refreshing this, you'll see that some of this actually gets updated in real time. And this is a sort of heat map visualization that you can use to identify hotspots, be it in a network, be it in a geographical zone, or so on. So that's just a sort of example of a stepping through right from creating the table. I didn't use the dashboard to do that, but I could easily have done, to inserting some data and defining the cube to visualizing it. And you see all I'm doing up here is saying select count, where lat, where long, group by those buckets.
Yeah, that's good stuff. Well, hey, this has been a great demo. Thank you so much, folks. That was Dr. Robin Bloor. You heard asking some questions after I sent a few questions over, but very interesting stuff. We've been talking to Tim Morton of Acunu. Nice job.
Thanks, Eric. Thanks, Robin.
Okay, folks. Take
Thanks.
care. Bye-bye.